Ты нас предупредишь, когда ты начнешь трансляцию?
Да, я вас предупрежу. Мне кажется, что я не могу транслировать одновременно экран и следить за трансляцией на YouTube.
Да пошло.
Да? Окей. Толя, можешь, пожалуйста, последить за трансляцией на всякий случай, пока я демонстрирую? Окей.
No, maybe I can upload presentation then.
Yes, if that's all right.
Тогда я загружаю презентацию, да?
Да, пожалуйста.
Okay. Good afternoon, good morning, good evening, good night to everyone who is joining this lecture or seminar for young scientists. We're very glad to make this few days of quite interesting, I hope, topic to present and discuss, which is quite important for studies of sediment transport and erosion. So I'm Sergey Chalov. I'm a professor of Faculty of Geography of Lomonosov Moscow State University. And here in the Zoom also I would present you first Anatoly Tseplenkov, Dr. Anatoly Tseplenkov. He's also the officer of Commission on Continental Erosion, which I'm currently the president-elect, and which is the main umbrella for these lectures. And Professor Alexey Konoplev, he's the head of this project, which is also stay on as a key organizer of these lectures. So I would take opportunity on this opening few minutes to say a few words about these lecture seminars. So it's very good. We have more than 800 registered participants from the world. We're very happy to see this interest for this session and from young scientists. We will have 4 lectures at the end. Unfortunately, one of the lecturers, due to unpredicted reasons, was not able to join the session, the seminar. So the main organizer is, as you see on the slide, is International Commission on Continental Erosion, called ICCE. It's the one of commissions of the International Association of Hydrological Sciences. It's actively in the field of science since 1981. The main direction of the commission is the sediment transport, nutrient and contaminant transfer, and erosion as the key research areas of the commission. So presently the commission have the 7 officers who are leading the actually the commission itself. So the activities of commissions is quite broad. We do, like on the first slide, you saw this some kind of publication, the special issues in the journals, and generally, of course, the more general idea is to bring together the scientists working in the fields of the mentioned research areas. We do regularly conferences, and that's on the slide is the quite big event in 2018 in Moscow, which is standalone ICCE conference, which was held in Moscow State University. Last year we met in Germany in Einstein and Ingolstadt University, and there was also more than 50 participants here. And so that's key activities of the Commission. And of course, these training and educational activities are now quite important. So today's lecture seminar continue the series of the same kind of event, which was started in 2020 in the online format, which was discovered this year. And in November 2020, we first time tried to make a such kind of school for young scientists in online format. And the topic was pollutant and sediment mobility in river system related to human impacts. There was 11 lecturers, and the audience was not so big as today, but also quite impressive. In 2022, we have same kind of events also, which was in the same format. So we it's already like a series of the events, and so we're happy to open today our workshop seminar, which simply continue the same kind of activities. All the lectures will be available in YouTube, and all the training which we have more or less at least tomorrow kind of training activity, which will be recorded and uploaded in the formats which will be available for the registered participants. So upon request, we will be happy to give the registered participants, those who will be in online formats, and we will be happy to, upon request, present the certificates of attendance if needed. Also, I should in the beginning say thanks to all the lecturers who agreed to join the formats. And regarding the ICCE Commission, the last thing which I need to say is that there is actually 2 days left to join the International Association of Hydrological Sciences Assembly, which will be held this year in October in Roorkee in India. So the final deadline for registration is the day after the 20th of February. So we have 2 days. It's a good chance to advertise this event. The Commission will be here presented. We have now also number of registered participants, and this will be also kind of erosion and sediment transport event for those who will be able to come here. So welcome to join. And also I will later talk about activities of the which are in parallel with our commission. So actually the main organizer of the events beside the commission is Moscow State University. Also a few things which can be interested, mostly maybe for the participants from the Russia, but of course this is quite useful for abroad. So there is a few conferences which are also in this topic are arranged by the scientific coordination of the erosion channel and fluvial processes inter-university council. And so we have quite big event this year in September in Rostov, which we invite those who are interested to come here and also meet manually. We are quite active in the commission, continental our commission of IAHS, and more broadly in making table for researchers working in the field of soil erosion and channel processes for the promoting the research. There is the special journal which started last year, and we're happy to announce it. It's published in under the roof of Makaryev Laboratory of Soil Erosion and Fluvial Processes, and it's have quite broad international level, and I hope we will go through that so you can be able to recommend this to use this print screen to use this information. So one more like advertising thing is related to the topic we talk about, is the special collection and call for papers in Anthropocene Coast Journal, Springer Journal, and we just opened under the roof of our commission this special issue, Contaminants and Sediment Transport in Estuaries and Deltas. So it's also the focus of the research in riverine scope. Please upload your papers, and it can be good to join our activities also in this format. We have it's in Russian language, but it's quite broad audience here. It's the let's say platform for those who interested in this field. It's a Telegram channel. It's quite broad information uploaded here. Up to 700 subscribers we have at the moment, and invite everyone who can be interested in this scientific area also to join and to follow the updates. We publish here short information about the most recent papers, the events in the scientific world, some conferences, everything like this. Just interesting facts are here. And with this, I would be happy also to introduce again the Professor Alexey Konoplov. He's the head of the new lab, which was established in Moscow State University, and under the project which is called like flow of potentially toxic elements. It's also the key organizer of these events, and I would ask and give a floor to Alexey to greet the audience, and then we will be able to actually start the lectures. Alexey.
Thank you, Sergey. Hello, everyone. Greetings from Fukushima, Japan. So, I'm a vice director of the Institute of Environmental Radioactivity at Fukushima University. Starting from last year, together with Dr. Sergey Chalov and several other principal scientists from Geography Department, we are leading laboratory of geochemistry of natural waters of Lomonosov Moscow State University. The laboratory was established in the scope of mega grant project funded by Russian Ministry of Higher Education and Science, fluxes of potentially toxic elements and substances in river basins, research methodology, quantitative assessment, and prediction. Research on erosion and river sediment transport is the key component of our project, since these hydrological processes are predetermining dispersal of potentially toxic substances in the environment, including transboundary transport. Also, the project is focused on knowledge and experience transfer to younger scientists and students. This is our honor to participate in organization of the online seminar and Young Scientist School. I wish all of you successful and productive conference. Thank you very much for your participation and kind attention.
Thank you very much, Alexey, for nice greetings. So we are happy then to move to actually lecturing part of the our workshop of our seminar. It's quite timely. It's almost time to start the lectures. So, and with this, I would be happy to introduce Professor Anirban Mukhopadhyay. Yes, so he's our first speaker for the workshop, and so we the format will be that if you're very invited to, I mean, the participants to ask the questions, please text it in YouTube We will then deliver this your questions and any kind of addresses to the speaker. And after the lecture, we'll have some up to what time we need to follow your questions and everything. And in the same format, we have all 4 days of the lectures until Friday. So yes, I think we can start. And floor is yours.
Thank you, Sergey. Hi, good morning, good afternoon, and good night also for someone I know. So you are very welcome and thank you for joining this seminar. And this will be interesting for you, I hope, for this total seminar. We have very nice presentations and also training sessions. And you can also ask questions about whatever is your query, and may not be, if it is not possible to answer you today because of the time, you can just ask me the question. I can contact you, or you can contact me also for any questions regarding my presentations or any other's presentation. So first, let me introduce myself. Just a second. So let me introduce myself first. I am Dr. Anirban Mukhopadhyay. I am assistant professor in Faculty of Geography in Kazimierz Wielki University in Poland. So my basic field is I am a geospatial modeler. So I use remote sensing and GIS technology and add with some other models like hydrodynamic model and other models, and I try to find out the cause and effect of a system. So right now here, I'll show you whatever we have done in the river of Ganges. Ganges river, we all know about this river. This is a big river and big river in the Asia, biggest river in the Asia. And a huge number of population actually depends on this river. And the sedimentation is a problem for as like any other rivers. Here also the sedimentation is a problem, and more specifically as this Ganges river is goes in Bangladesh and India, the water management is a huge problem. And for these water management issues, there is two ports in Ganges river, one in Calcutta, one in Haldia. Haldia is in the eastern part of the Ganges river. So this management of these two ports is becoming very difficult day by day due to this sedimentation problem. So we try to address the sedimentation from this Ganges river and how we can solve this problem. We are trying to do this thing. So I'll show you all the findings and everything. So first, let me go like. So as we all know that this Ganges river is a major transboundary river in South Asia. It originates from the Himalaya and the Gangotri Glacier, and it flows first through India and eventually goes to one part in Bangladesh and one part is India. So, and forming the largest delta of the world, the Ganges, Brahmaputra and Meghna Delta. And this delta has more than 20 to 40 crores people lives here. And as you know, and this is the main agricultural land, mainly in terms of rice in this Southeast Asian region. So this importance of this river is very huge. It's approximately 2,500 kilometers long, and it has a lot of tributaries and attributaries, and most importantly, Yamuna, Gandok, Koshi, and a lot other. So just to give you a picture about the vastness of Ganges and the sedimentation as well as contaminants and other problems related to the transportation, I'll just show you these pictures. And this is one part of the Ganges river where Jamuna and Ganges meets together. Like in these confluences, in each year, normally there is a pilgrim activity. It's called Kumbh. And this year in 2025, here you can see the left one. This year it's some special event of Kumbh. It's called Mahakumbh Mela. And here 40 crores, means 400 million visitors came, and it's still going on. It will go on till 27, but it still will go on for, say, for more than 15 days. So just to understand, means the sediment problem is a issue. But if in a river bank, there are 400 million visitors for 1 month or 2 months, then you can easily understand how the river is being contaminated or polluted. Though there is a pollution restriction, there are so many measures taken now these years. But the thing is that this much of population, just, I think if they march on, the dust is enough for the huge sedimentation problem. But this is happening here in Ganges River. So this is for the vastness of this study, I wanted to share with you. Now, actually, I concentrate in the estuarine part of the Ganges River. So that is here. This is the estuarine part of the Ganges River. So our main focus is that in this estuarine region, there is one port here. Here is one port called Haldia Port, and one port in Calcutta itself, that is riverine port, and Haldia is the estuarine port. So the main problem of this Haldia port and Calcutta port is that a huge sedimentation. Due to lack of water flow, a huge sedimentation is happening in the estuarine region. That is why what happening, the channel, the shipping channel, they always keep shifting, and also regular dredging is required. And it is being done, and dredging comes with a huge, not only huge cost, but also damage to the ecosystem. But it is not possible to maintain the shipping challenge due to this sedimentation problem. So we try to find out what is the root cause of the sedimentation problem, this in the lower part of Ganges River. So that was the main focus of this study, to how to manage or understand what is the causing this sedimentation. So after I'll show you. So this is the estuarine region. Now here you can see from 1990 to 2020 is a gradual increase of these island areas in this estuary. So what is causing these things? If the sediment is not coming, then it's not possible. So there is a huge sediment is coming, and also the tide is playing a critical role. So whatever the dredging material they are dredged and dumped in the open sea, they are keep coming back. So this is a very dynamic estuary, and with a very high tidal fluctuations, and as well as current and flow also in the estuarine region. So all this is almost impossible to maintain the port. So right now, this is somehow Haldia port. Right now, the Haldia port is in verge of closing. So because this huge sedimentation and the shipping channel blockage. So now, for that, we just started what is happening in this river. So in terms of erosion accretion of the river bank, in terms of sediment concentration, load and discharge, and finally the changing morphology adjacent islands and port affairs. We did all these things. We used some satellite images and also some suspended sediment concentration measured by some in existing literature, as well as we also measured the suspended sediment concentration. And now also the work is being going on. In last time in monsoon period, we have collected the sediment concentration, and this after post monsoon also we are going there to collect the samples this year. So because we need to study it continuously, otherwise we cannot understand the total scenario, and we cannot maintain, because it's changing like hell. Means, and on top of that, there are severe cyclone in this area. Yeah, Samphan, Ayla, they keep coming, and the frequency is increasing, and also the devastation is also increasing due to climate change that we all know. So in this area, we have to keep monitoring always to come up with some sustainable solution. So that is what we are trying to do in this area. So this is the methodological flowchart. Just to understand, we use the satellite images and we go for some feature extraction using GLCM, and then the support vector means AI-based learning deep learning classification method to come up with the changes in the estuarine, and as well as we use some water index also. And from some secondary in situ SSC data, we have come up with the final conclusion. So I'll go step by step. So we all know the NDWI is a very easy to do and easy to work on this type of huge river, long river, to identify first the water area. So we need to identify first the water area, means which areas are water, which are not. So there are several methods, but this is a easy to do method. So we did these things in NDWI. So we have just identified the water areas of this Ganges River, and we omit all the tributaries. Just for this Ganges River water area we needed to do. So this has some formula. We use Google Earth Engine to do this. And then after doing this NDWI, we go for MNDSSI. So this is a suspended sediment concentration index. So this use also the bands of the satellite images, and from this formula we can come up with a figure in which the value ranges between -1 to +1, where -1 represents the highest concentration and +1 represent the lowest suspended sediment. So this modified normalized difference suspended sediment index we use to understand the sedimentation pattern in this river. We have some field data, and from this field data we incorporate the corrections factor here and come up with some more corrected this legend. So here we use pre-monsoon, monsoon, post-monsoon for consecutive years, and we are keep doing this to understand the total sediment concentration and how the sediment is flowing and where is the maximum sedimentation, and then likewise where is the water most sediment is there. So as usual, in pre-monsoon there is a higher sedimentation, and post-monsoon also higher sedimentation. In monsoon there is a discharge increase, so we can come up with some less sedimentation. So this is the zooming of some part of this Ganges River, and you see how this river is here also. In these places we are going to see very soon a oxbow lake like this, and this is keep happening. The track of the Ganges is keep changing every year almost, and it's causing a severe coastal erosion, riverbank erosion in the upstream of this area. And that's the whatever we have found out, that the riverbank erosion is a huge problem in the Ganges River. And the amount or volume of the sediments coming from the erosion is huge, and that sediments we cannot trap anywhere. So that sediment is keep coming in the estuary part, and they are settling down, as in the estuary part the flow velocity etc. And the widen estuary is widened, so the sediment keeps settling in the estuary part, and that is causing a huge impact on the shipping channels. Now also we tried to understand what are the land cover in surrounding this long river. So for that we need to classify this land cover also to understand the scenarios of the surrounded land use land cover, means what are there, means the erosion part mainly happening in where and which area. So all these things we have used for this we go for land use land cover also. And finally we come up with what are the changes happen in this track of this river from the Farakka barrage to the total estuary. So we take, there is a barrage in Farakka from where the Ganges River goes in two ways, one in Bangladesh part and one in India part. So in India part, we work on this river and come up with what are the changes in the land cover surrounding the track of this river. We found that the valley area of the Bhagirathi Hooghly is increasing. That's a very interesting thing. If the valley is increasing, means the river is meandering much more. So the seismicity index of the valley side shows that the channel morphology is meandering by nature, which increases slowly. So the seismicity is increasing and it is creating more and more erosion in that area. So that part also been covered in this area. So here we go for the total river side districts and blocks, and from where we can come up the which part is having the more erosion, which part is having some accretion, and where is the we need to focus for this erosion and accretion issues. So we do the shoreline change envelope process for this river, for the right bank and for the left bank, to see the differences between which part of which bank is having more erosion issues in this area. Now we go for the erosion accretion part from 1990 to 2020 part, 10 years apart, so 3 decades we are doing. So now we will do like 2025 also for the next part of this, to understand that how it is actually happening in where. And we come up with the results that the erosion and accretion part, how it is happening. So this slowly that this is showing that the accretion, main accretion zone is happening in the estuarine region. That is for the natural thing that it normally happens in the estuarine region, but it is happening in a very huge rate and it is continuously accreting in the estuarine part, and that is mainly causing the problems in the shipping routes. So for this, what we have to do, we just come up with the idea that the erosion part in the upstream river is we need to stop somehow. So, and we also go by, this is a part of this, so we also go by the all the villages in the side of the river and come up with the areas of erosion in the right bank and also in the left bank. So to inform the local authorities or disaster management authorities or the government or waterways to how to prevent and where to take actions like this. So this part we are discussing with the West Bengal government also, and this is a good follow-up for this. Now the Navadvip is another important area in this Ganges River. It's just like I shown you the Kumbh, there is a huge people comes. So Navadvip is another pilgrimage area of the India, and there also huge people goes each year and almost every time. But in the place of Navadvip, there is a very interesting part of the seismicity as well as the erosion problem in the Ganges area. So we just keep focusing on this area, how it is happening and why it is happening. So here we can easily see the river is being changed, like the path of the river is changing. And whatever the change, it added the accumulation of the sediments in the river. So we are trying to calculate the volume of the sediment from this river erosion. And we come up with some futuristic prediction that what might go, and in the near future we have predicted up to 2040 that which bank is going to which direction and where the erosion rate is higher and where the erosion rate is lower. So from that we can accumulate the rate of the sedimentation in the river as well as the sediment coming in the estuary. So that will help us to prepare for the planning for the ports and the shipping channels. We also take some cross sections of the river and see the changes in the river bed, how it is changing since 2000 to 2040, and we also projected likewise then in 2040 how the projected line will be. So this is the total erosion deposition map of the river from the Farakka barrage to the Sagar area. Now this erosion vulnerability zonation. So we have compartmentalized the whole river area, and for each block we have calculated the erosion vulnerability from high to low. So in the top upper part there is a very less erosion problem. But in the middle part of the river, this part, there's Navadvip area, Nadia area, all this area, this is having a very high erosion problem in this river. And we blockwise, we have analyzed which area we need to give more attention for this erosion problem. So this will give us a total picture of this erosion problem, and we are keep looking in this problem so we can understand the scenario. Now, the sediment load is assessed in terms of volume concentration of sediment on the riverbed in different stages as follows. So we know the erosion area, and we know the level of the soil level. And from that, we calculate the sediment volume or sediment load, and how the sediment and how much the sediment. We try to go for some quantitative analysis. So how much sediment is coming from this erosion, and how in which area is giving the maximum erosion is happening, and erosion and accretion, and where is the maximum sediment load is there. So we can come the Navadvip to Sagar is very high, Diamond Harbour to Sagar, then follow up by this, and likewise. Also, we study the sedimentation across the estuarine area in this map. I also shown in Gandhi data due to sediment concentration, and it is keep increasing in the island areas. So we can see these things. Now we go for the sediment concentration in the estuarine in pre-monsoon and post-monsoon from 1990 to 2020, how it is changing. And these are the two main shipping channels which are going for, this is for Haldia and this is for Calcutta, which is impacted from this huge load of sediment in this Ganges estuary. So this helps us to understand that how we can manage the sediment channel, and also the sedimentation, if we have the bathymetry of this area, which is not available to the open domain because of the restricted use. But the port obviously have those, so they can plan their dredging where to dredge for this sediment thing. Now this is we do for another reason, that how the sediment is coming, but the sedimentation in the previously there are a lot of rivers and tributaries in this area from Farakka to total Sagar. This is Sundarban area, and this one is the estuary of the Ganges River. There are a lot of tributaries, and a lot of fresh water keep coming, and all this fresh water brings sediments to these Sundarban regions also. Now what happened from 1990 to 2020, within this period also, there are a lot of blockage or dead canal in this total study area. So we have identified this dead canal or blocked canal, and on those canal now there are agriculture, settlements, and all these things happen, so that the connectivity of the rivers are blocked. And what the main reason, the sediments from the upstream, they cannot come in this part of this Sundarban area. So this part is become the sediment deprived area, and whereas this part is having more and more sediments, because now no sediment can come this area. So this area is under a huge erosion problem. And the active mangrove area are decreasing day by day. So, and also the fresh water is another issue. For that, the salinity of this Sundarban part, this is the mangrove part. Sundarban is the biggest mangrove, single patch mangrove forest in the world. So this is the Indian part, and then Bangladesh part is there. So this part of the Sundarban, the salinity is keep increasing, and that is why the more salt tolerant species we can see only here. And in the Bangladesh part but in Bangladesh part, there are a lot of fresh water is coming. So that is why the name of the Sundarbans come from the Sundari tree. So those trees we can found in the Bangladesh part, and slowly the species are being changing in this area. In this area, the more salt tolerant species are coming up, and the freshwater loving species, they are going to in the Bangladesh portion. So these interconnectivity or these date canals, they are playing a crucial role in the total water transportation or water domain or water ecology system of this delta area of the Indian part of the Sundarban. So there are a lot of date canals, and these canals are keep closing every year. Each and every year there are blockage. So this is also a severe issue. So we have to think about this blockage of these natural channels. So for this natural challenge, we just do the drainage density of this whole study area, and it is easily been seen that the drainage density is decreasing in the whole study area. Is drainage density is decreasing. So for that this part is deprived of the sediment, and this part is a huge sediment is coming from the erosion. And for as the drainage density is decreasing and there are a lot of date channels, what happened for any cyclone and something comes, these areas are inundated and the water cannot go out. So they keep staying for there in long time. So we have used some SAR data analysis to understand that what happens when the Amphan, Yas, like these are the cyclones. So they came in this area and in the water inundation part, where water inundated and how it is inundating. So these all are the parts of our whole studies. So here we see the more in this part, water inundation is huge portion in these areas. So that's a also issue due to these things. Now, as these are the problems we have identified, we have studied, and other people are also studying. And now these are a few pictures of this erosion problem of this Ganges river and how it is happening. So you can see. So in conclusion, we just see the estuary's ability to hold back upstream water is declining due to massive inflow of the sediment filled water from the upstream erosion, and that is causing the more damage in whenever any natural calamity is happening. So in each cyclone, the devastation is increasing, and also flooding. The flood is having more impact than the earlier thing. And Bhagirathi estuary has led to a complex interplay between fluvial and marine dynamics that I also told, because there is tide is very high and frequent, and it's happening, it's keep throwing back the sediment in the estuarine part, and which is totally having some issues. So I think this is, I can give you some insights of the Ganges river and how its dynamics is happening and how we are trying to solve this issue. So now,
thank you very much, Anirban.
Yeah,
It's a really insightful lecture. So dear listeners, our participants, you're welcome to ask your questions in the YouTube chat. Please feel free to ask anything, and we will discuss there. So we do already have some questions, Anirban. So a question from Ali Basir: how can I anticipate the channel center line in 2040? I think it means how can I predict the channel center line in 2040?
Actually, we did not predict central line. We predict the erosion and accretion rate. And according to the erosion and accretion rate, we go for the boundary of the river or river bank. So we assume that if river bank shifted, then the central line would automatically shift.
Right. So I guess that if you're predicting the shift of both banks, you can predict the shift of the central line.
Central, yes, that's the.
Right. we do have a question by Sylvia Zelagi. It asked a bit vague. What caused the land loss? I think, Sylvia, if you're listening, can you please repeat your question because it's not clear what you're asking?
I think she is asking that why this much erosion is happening in this area. Is that true?
Yeah. Yes.
Yeah, and now the erosion is happening. First of all, it is a deltaic plain. So the lot of the soil itself is very loose in some places. And also there is a very irregular discharge, as well as in that area, the flood is a issue. Each and every year, some area, these areas keep flooding. So making the soil more and more loose. And all these things accumulating and having erosion. Erosion actually is a natural process. So it will keep happening where it happens. So you cannot withhold all the erosion, but we can some pocket we can understand that in this area maybe we can make an embankment or some earthen embankment type of thing, and they are also starting. Our government is working hard in this area. So West Bengal government is doing very good job for irrigation and this erosion problem. So this part is being done in this area, but natural erosion keep happening, and this area is a highly flat prone area. So soil is quite loose and it's happening because no rocky area in this part, all alluvium and soil, because this is a delta. So erosion will keep happening.
Yeah, thank you. I think you answered this question really good. I do see a lot of questions about the data and methodology used. So I'm also really curious about that. Is something of this figures, tables, and results are published somewhere in any
Yes,
source?
yes. One paper published in Water. So I can share it here, the link, or what should I do?
Yeah, it would be great if you can share with us links, and we can then send email to all our participants
Just a second.
with the. You can do it after.
Okay.
After our talk, yeah. Because there's really one interesting question about the erosional vulnerability zonation. How did actually you estimated the zonation? What are the selected parameters?
Sorry. Is some big.
What are the selected parameters for erosional vulnerability zonation, and how did you calculate the?
Yes, so for the erosional vulnerability, there are 2-3 factors we have taken. The first of all is erosion. How is erosion happening? Where is higher? Where is lower? Second, we also use the land use land cover. Means what are there in near the erosion land? Means what land are being eroded? That is having some importance, some weightage also. Also, we did some population analysis also, that how many population is being vulnerable for this erosion. So all these and few other geomorphological parameters, something like that. So we added all these factors and we give weightage and ranking. Then we run some AHP and all these things and come up with this total final erosion vulnerability.
Okay.
Somehow multi-criteria MCDS method we have used.
Right. Actually, I do have one more question from myself. Oh, here's one interesting by Abdul Majid. Why have you used low resolution DM, digital elevation model, for this study while having high resolution digital elevation?
Yes, we are keep updating ourselves. No problem. That's what's done. What done? We are keep updating.
And what resolution have you used?
Resolution is we use Landsat mainly, so 30 meter. Everything 30 meter.
No. The question is about the digital elevation model.
Digital elevation we use SRTM 30 meter.
Okay, cool. Yeah. Fair enough. So my question was about the the stability of the delta. I've noticed that when you show us maps of the delta channels, comparing 1990 and 2020 periods, I've noticed that apart from seeing a lot of variability in small canals and appearance of dead canals, overall the shape looks more or less the same. So comparing this the delta channels, downstream delta channels, I have a feeling that it is pretty stable. Is it true, or is it just a false impression based on your map?
First of all,
is there a mangrove defense, like mangrove vegetation helps to stabilize delta?
yes. So first of all, this whatever I have shown, this is a huge area. Okay. So by seeing the map on the screen, we cannot understand how it is changing or something like that. But delta, it keep it safe, no problem. And mangrove is very, very, very important for saving this delta. So these mangroves in the Sundarban, lower Sundarban part, it is saving, like, means crores of people are inhabitant in the upper side of the mangrove part. So mangrove is very, very, very important, and that is why means in both of the country, India and Bangladesh, we both are working to save this mangrove. And like in West Bengal government, they have initiated a special program for mangrove restoration parts, and they are doing huge mangrove restoration also in our Indian part of Sundarban part. So forest department also doing those things, those parts, and also a lot of NGOs and organizations, they are working on this mangrove restoration part. So mangrove is playing a huge role in this delta management system. So yes, mangrove is good, very, very good and interesting and powerful thing to have. We are lucky to have that. We have mangroves in the coast.
Thank you. Well, I think it's time to finish our talk, our lecture for today. So thank you very much, Anirban, for so good presentation, and thank you everyone who attended. We're looking forward to see you tomorrow, all of you, at the same time. We will have let me so tomorrow we will have a lecture by Sergey Chalov and Kristina Prokopieva about the usage of Google Earth Engine for remote sensing application for suspended sediment transport assessment. So we are starting at 10 in the morning, Moscow time, so it's approximately 8 in the morning Central European time. You can take a look for the time zone conversions on our website, hydro-geochem.ru/IHS workshop, or you just can subscribe to our YouTube channel and you will get a notification as soon as we will start our lecture. So thank you very much, everyone. Have a good night, day.
Thank you.
See you.
See you. Bye-bye.